All right, so today we're going to take a quick look at the 8.3a notes. This deals with special right triangles. All right, we're going to have two types of special right triangles that we really focus on this semester. And the first of them is going to be a 45, 45, 90 triangle. Now, when they say 45, 45, 90, they're talking about the angles. All right, so we've got a 45-degree angle, 45-degree angle, and a 90-degree angle in a triangle. All right, which really means it's going to be an isosceles right triangle. All right, because we've got that 45 on each side, so we know those opposite legs are congruent. All right, now, just a quick little exploration to get us to a rule. So I've got draw the diagonal in the square, so let's go ahead and do that. All right, when I draw that diagonal in, you'll notice we get two triangles. I'm going to pull one of the triangles out. I'm going to pull the bottom right triangle out by itself over here. All right, and we've got a 4 on this side, a 4 on this side. All right, the diagonal in the square, we know it bisects the opposite angles because it's also a rhombus. So I've got 45 and 45 there. All right, so it said find the length of the diagonal, so I'm going to do leg squared plus leg squared equals hypotenuse squared, which I'll just call d for the diameter, or diagonal, sorry. So that's 16 plus 16 equals d squared, or 32 equals d squared. Square root of both sides, and I get a 4 root 2. All right, so my diagonal length in this one is 4 root 2. All right, now, the next one asks us to go on and look at this in a more general case. We're going to approach it exactly the same way, but this time we're going to see if there's a pattern. All right, so we're going to stick with a square with n on each side. So when I draw on that diagonal, I still get a 45, 45, 90 triangle. All right, I'm going to pull that off to the side over here. So we kind of got it by itself. So I've got n on this side, n on this side, and then I've got my 45s in each corner. All right, so I can apply Pythagorean Theorem again, so I get n squared plus n squared equals d, or diagonal squared. That's 2n squared equals diagonal squared. So I'm going to take the square root of both sides, and when I do that, I get that the diagonal equals n squared we can simplify, so we can pull that out, but then we're left with the 2 inside, so n root 2. All right, so this side over here would have to be n root 2. Now notice that matches the last one. The side length was 4, and the diagonal was 4 root 2. All right, so what this allows me to do is generalize and say, you know what, if I had a square that was a side length 10, all right, that's my n value, so this diagonal is 10 root 2. All right, and that's kind of the process we're going to use with these special right triangles to work through, is we're going to use patterns. All right, so the first one, again, 45, 45, 90. So you notice we've got this here, it's leg, leg, and hypotenuse. All right, basically what the rule says is we know that the two legs are the same, and the hypotenuse will always be that leg length times root 2. All right, so it's leg times root 2 gives you the hypotenuse. Now, the whole idea of this is really just to save time. It's to give us a shortcut. All right, so if I look at these problems on this page, in number 1, for example, I've got an 8 on the side. It's clearly a 45, 45, 90 triangle, so I know I can carry 8 over to this side. All right, and the diagonal is going to be that 8 times a root 2. All right, so we could go right to x equals 8 root 2. But what I find helpful for a lot of people is a lot of times if we go in here and just on the inside of the triangle, we draw in our little relationship, so AA and a root 2. All right, we can almost think of it as like an equation. So that side I know both pieces, a equals 8. So then when I go to this side, it says that the x equals the a value, which was 8, times root 2. So we get our 8 root 2. All right, so carrying that same idea over to this next one, all right, I've got a 45, 45, 90 triangle. So I'm going to put my labels in. So leg is A, hypotenuse is a root 2. All right, so I look for the piece that I know the full side for. So I know a root 2 equals 3 root 2. All right, if I divide both sides by root 2, I get a equals 3. All right, so at this point I have the a value. The x we're looking for equals a, so the x value is 3. All right, following the same process over here on this next one, I've got A, All right, and a root 2. It's very clear that we have an isosceles triangle here because both sides are x, both legs are x. So this has to be a 45 and a 45 here in the corners. All right, so again, I look for the piece that I know both parts of. So a root 2 equals 18. I'll divide both sides by root 2. So a equals 18 over root 2. But then I need to clean it up a little bit, so I'm going to multiply top and bottom by root 2. So I get 18 root 2 over 2, which simplifies down to a 9 root 2. All right, and that would be the x value that we're looking for, all right, because x did equal the a there. All right, so x equals 9 root 2. Now, when I look at it, we have to be comfortable enough with this that we can pull it out of problems when appropriate, but also ignore it when it really doesn't come into play. So when I look at the examples down here, I've got a 45, 45, 90 very clearly marked. They gave me a leg, so I know that's a, and a root 2. So a equals 8, and x was a, which is 8 times root 2. And I get to my answer. All right, now, the next one, I don't have any information that points me to a 45, 45, 90, so I've got to rely on old tricks. All right, so one thing I notice is here it looks like I've got a 5 times 7. This side I've got a 5 times 10, so this side's going to be a 5 times something. All right, so I'm going to set up Pythagorean Theorem with the scaled down version. So we'll call it c for now. So c squared plus 7 squared equals 10 squared. C squared plus 49 equals 100. C squared equals 51. C equals root 51. All right, but this is scaled down, all right, by a factor of 5, because it's a 5 times 10, 5 times 7, 5 times whatever we get for C. So when I bring that back up, the x value would be 5 root 51. And 51 is 3 and 17, so that does not reduce anymore if we try and do the prime factorization there. All right, going to the next one, I've got x and x. So what I noticed right away, hopefully, is that this is a 45, 45, 90. So I know my relationship is a, and a root 2. So this is the side I know. So a root 2 equals 18. Divide both sides by root 2. And then I've got to rationalize my denominator. So I'm going to multiply top and bottom of that by root 2. So I've got 18 root 2 over 2. And then I can reduce a little further, and I get 9 root 2. All right, then I look to what I'm being asked for here, which is x. And the x value just equals a, which is 9 root 2. All right, we've got our answer on that one. Now, when I go to the next one, hopefully I notice right away that it's at least a rhombus, and then I notice a little further that it is a square because we have the right angle marker down here in the corner. All right, so now it asks me for x degrees, all right, and the x degrees has to be 45 degrees because we know that we've got 13 and 13, so that's a right isosceles triangle. Next, it asks me for the diagonal length. So if I remember our relationship, a root 2, that last side is going to be 13 root 2 because a equals 13, so y equals 13 root 2. All right, we've got one last problem on this note set, and then you're good to go for the homework. So the last problem is a composite figure. So there's 3 different shapes in here. And we're going to break it up accordingly. But first we're going to make sure we read the question so we don't do the wrong thing. All right, so it says find the perimeter of the trapezoid. All right, so if I wouldn't have read that, I would have gone down a bad road because I probably would have looked at area for some reason. All right, but it asked me for the perimeter, so I've got that now. All right, so I need to look at the pieces that are missing. All right, so first of all, I know that 20 carries straight down because I've got a parallelogram there. All right, so I need this piece here. I need that x. I'm also, I can carry this 15 over. So we got 15 there. And now it's 45, 90, 45, so I can carry that 15 down here as well. All right, which means I just need this side out here. All right, so I'm going to call the 2 things I'm looking for x and y. All right, and I'm going to start with y in this one. All right, for y, that's a 45, 45, 90 triangle. So I can use my a root 2. Right, so y equals a root 2, but a is 15. So we have 15 root 2. All right, that gives me the first of the two components I need. Then I go to x, and for x I can use Pythagorean Theorem. X squared plus 15 squared equals 39 squared. All right, and this is one where I'm going to definitely want to grab a calculator. All right, so I've got 39 times 39 gives me 1521. All right, I've got 15 squared, which is 225. All right, so I'm going to subtract 225 from the 1521, and I get 1296. All right, now I'm going to take the square root just out of the hope that that simplifies. And it sure does. It gives me 36. All right, so my x value here is 36. All right, but it asked me for perimeter. All right, and perimeter, I add up all the sides. So I've got 39 plus 20 plus my y, which was 15 root 2, plus the 15 plus the 20 plus the x value, which was 36. All right, so at this point, it's really calculator work. We can add those up real quick so you've got the right answer to compare versus. And unfortunately, my calculator just died on me, so I'm going to jump to my phone calculator here real quick. And I've got 39 plus 20 plus 15 plus 20 plus 36. That takes me to a 130. But I also need to add on the 15 root 2 that I skipped over when I ran through that the first time. All right, and again, I kept that separate because I wanted to combine just like radical terms. All right, so that's our perimeter. So that takes us through the notes for today's lesson. I hope that helps. Bring your questions tomorrow. Bye.